Today we're going to be combining like terms. We've talked about the vocabulary for determining which terms are like terms, so let's review that. Remember, like terms, they are constants, and those are just numbers, or like terms have the same variable to the same power. Okay, it's very important that you remember the definitions for that, because otherwise you're going to have a lot of trouble. All right, so we got 3 problems here. We're going to just find the like terms. Okay, so do we have any constants? Only one plain number, so it doesn't have a like term. Okay, these are C's, not C's. No, I have some C's here. We have C squared. They have the same variable, but they are not to the same power, so these are not like terms. And then we have a C and a C. It doesn't matter about the coefficient. Remember, coefficients are the number that you're multiplying by a variable. You're only looking at the variable and the exponents that go with the variables. So the like terms for this one are 4C and C. Okay, the next one, I like to start with constants because people usually overlook constants as like terms. So this is a plain number. Do I have any other plain numbers? Aha! So I have 8 and 23. Those are like. Now let's look at the ones that have variables. Remember, we're looking for the same variable to the same power. Well, y, and y. Now we look at the exponents. Y cubed, that's not y cubed. That is y cubed. So I have to use a different symbol for this one so that we know that it doesn't match the pair that are constants. So I'm just going to put a rectangle around those two to let us know these are like terms and these are like terms. These are y squares, these are x's, not like terms. Okay, you try the next one, pause the video, come on back when you're done. You got this pair as your like terms. These are D's, C's, and that's a constant, so none of those are like. Okay, now here comes the fun part. Combining like terms. Here we're just determining what's like. Combining means we're just going to put them together. Sometimes we'll add to them, sometimes we'll take away. It just depends on the sign in front of the number. First, I like to talk about like terms with fruit. Okay, so right now we just have a big pile of fruit. If I said I have strawberries, bananas, and apples, does that really tell us anything about this pile? No, it just tells us the kinds that are in there. It doesn't tell us how many of each kind. So let's separate and determine which ones are like. I have 1 strawberry, 2 strawberries, 3 strawberries. So instead of writing out 3 strawberries, I'm going to use 3S for strawberries. Okay, let's look at the bananas. I'm going to use a different symbol because it's not like the strawberries. Okay, 2, 3, 4, 5. I have 6 bananas. And so I'm going to use the variable B for bananas. Last, I'm going to combine my apples. So I need a different symbol for that. So I'm just going to put a little cloud around my apples. There's 1, 2, 3, 4 apples. So you would write that as 4A. Now, in order to be able to put all this together, we're going to put a plus sign in between each of the terms. Because I have 3 strawberries plus 6 bananas plus 4 apples. I cannot combine this or simplify this any more than I already have because these are not like terms. So you're done. All right. So when you see the directions simplify, I know you think about fractions. We use those directions when we were evaluating expressions. We will also be using them to combine like terms with our expressions. So simplify for these. I want you to write this down. We want as few terms as possible. And we talked about this when we were just simplifying expressions. And we took something from 5 terms down to 4, down to 3, down to 2, down to 1 term. Here we may not end up with 1 term. Okay, this one has 3 terms, and that's okay. They're all not the same. Okay? All right. I want you to put the marks on here like I am because it will help you to visualize which ones you've used, which ones you haven't used, and which terms are like terms. Okay? The other thing I want to remind you of is the sign in front of a number goes with, goes with the number. Okay, if there's no sign, then you know that it's the first number in your problem. Here, this sign really goes with that 8, so it tells me that I'm going to be adding 8 if I can put these together. You don't know if you can put them together until you look to see if they're like terms. Okay? Only combine like terms. Can only combine like terms. All right, so here we go. I always circle the first one. I don't know why I like circles first, but I do. So I'm going to circle my first term. These are A's. And then I look at the next term. Are these A's? Yes, they're to the same exponent because they don't have one. You don't need to worry about the coefficient until you actually try to put them together. Remember, the coefficients do not determine whether they're like terms. Okay? When I am going to circle this term, which would be the second part of my problem, I need to circle the sign in front of it to let me know whether or not I need to add or subtract. So we're going to do 2A plus 8A. So think of it like this. I have 2 apples. I'm adding 8 apples. So that takes me to 10 apples. And that's all we can do. There's no need to box or highlight your answer because we got a lot of boxes, circles, and all kinds of shapes in our problem. And since the only thing down here will be your final answer, there's no need to highlight or box your final answer. Okay, so we went down from 2 terms to 1. This one has 1, 2, 3 terms. If we're going to simplify it, we're going to see if we can get it down to 2 or 1 term. All right, start with the first. Remember, I like to circle first. Okay, these are A's. Are these A's? Nope, not like terms. Are these A's? Yes. So I'm going to combine or put together 5 apples and these 3 apples, but I don't know how to put them together until I look at the sign in front of the second number in my problem. So I have 5A, and then this says minus 3A. That's why the sign in front of the number goes with the number. That lets me know I have 5 apples, and I'm taking away 3 apples, so that leaves me with 2 apples. We're going to bring down this sign, because that's what's next after the first term. And we have a B. I'm going to mark it with a rectangle because I want to make sure every term has a mark on it. That way you know you've looked at everything and haven't skipped over any of the terms. A's and B's are not like terms, so you're done. So we could only get it down to 2 terms. All right, let's look at the next one. Now this problem is a little different because it has a constant. These did not have constants at all. Okay, order of operations says you do your parentheses first. Well, we don't have any of those. And then it says you need to do the exponents Next, even if your variable has an exponent, which these do down here, we don't know what k is, so you can't square it. We don't know what k is. But we can take care of that 4 squared, okay? I want you to underline it, just like we did in our plain old expressions. And we're going to write 4 times what? That exponent tells us to multiply by, that's right, itself. We need 2 4s in our problem. So 4 times 4, which is 16. So I'm going to mark it out, and I'm going to put a 16 here. Okay? All right, after you do that, you do multiplication division, just like all order of operations. Well, we don't have anything to multiply because we don't know what our variables equal. And add and subtract is last. So that's when you combine. Adding and subtracting is always combining like terms. Circle the first one. We have 16 mangoes, no mangoes, mangoes, no mangoes. All right, so we're going to put our mangoes together. Remember, the second term of what you're putting together, you have to circle the sign in front so you know whether to add or subtract. I'm not even worried about that 16 right now, and I'm not worried about that one. There's my math problem. I have 16 mangoes, and that looks like there's a plus, but that's not in front of what I'm doing. My pen's not big enough. Minus 5 mangoes. 16 mangoes minus 5 mangoes. Mental math lets us know it's 11 mangoes. And now I'm going to look at my next term. I'm going to bring down this plus because that's what's next. Okay. I'm going to put a rectangle around the next term. I have 16. And then I have another 16, but this one has a minus in front of it. So what is 16 minus 16? Oh my gosh. They cancel out. There's nothing left. So instead of writing 11m plus 0, the only thing you need to write is 11m because this is not simplified. There's 2 terms there. You need to write it as one term, which is 11m. And this one we do need to highlight our answer because we have 2 lines of work there. I prefer not writing this at all. Since I did these and got 11m, these cancels out. I only have 11m. I only write this. I don't ever write that one. Okay? All right. Let's see. I want you to try 7, 8, and 9. Pause the video, come back when you're finished, and we'll see how you did. Okay, welcome back. What I decided to do was not only use different shapes, I used different colors to help my like terms stand out. One thing you need to make sure you do when you're finished, or at least think you're finished, you need to make sure that every term has been marked. This one was tricky because of that imaginary 1 in front of the k. So you would do 4k minus 1k, which is 3k. I hope you remember to do your constant with your exponent first. So 9 minus 5, 9 plus 5 is 14. Okay, if you need help, go ahead, pause it, try to rework it and see how you do. Let's look at the last one though. The last one says to write and simplify an expression for the perimeter. Okay, perimeter means you've got to go all the way around, so you're going to add all sides. Okay, well with rectangles, we know there's 4 sides, so we can't just add these 2. We also know that opposite sides are congruent or the same. So if this is A, we know this is also A. Oh, I probably use those colors. And then if this is 3b plus 5, then this side is 3b plus 5. Okay? So now we just need to write the expression and put it together. Alrighty, so I have, you can start wherever you want. I think I like to start at the top, like a clock, and go around. I have 3b plus 5, and I'm going to add to that an A, and then I have another 3b plus 5, And you could even stack it if you wanted to. You could put the 3b plus 5 here. And we have the fourth side, which is another a. So we're going to add those together. Okay. All right. So we have 3b plus 3b. Oops. Sorry, guys. Plus 3b. So that would give me 6b. And then I have a plus 5 and another plus 5. So that means instead of just adding 5 and 5, we're going to add 10. And then we have, oops, don't forget, that imaginary 1 is here and here. So 1a plus another 1a is 2a. And these are all different terms, so you're finished. Okay? Another way that you could have done that one, if you think the stacking method is a little confusing, you could have just listed it all out as like 3b plus 5 plus a. Well, I'll just do that. Plus a plus 3b plus 5 plus the last side over there, a. And then you can look for your like terms. Okay? 3b plus 3b is 6b. You bring down your plus. We have 5. Oh well, same color, but oh well. Plus another 5 makes 10. And then we have our imaginary 1s here. And we have, that should be a plus. We have 1a plus another 1a. 1 apple plus 1 apple makes 2 apples. So there's 2 different methods for doing this. You got to find which one makes sense. Just remember, guys, this is not easy at first, but you've got to have a good grasp on the definition for like terms before you can do any of this. Like terms have the same variable to the same power, and constants are also like terms. That means we can put them together. We can't put things together that are not like terms. Good luck.